Hello, my name is Gunter Weser from GWJ Technology, Germany. In our video tutorial today, I would like to show you how you can integrate a gearbox housing as a step file from the CAD system directly in the multi-shaft system. And I show you this in our system calculation software SystemManager. This is an extension of our standard calculation software solutions eAssistant and TPK. eAssistant is the web-based solution and TPK is the desktop solution. And the single calculation modules for the different single machine elements like for shafts, bearings, shaft and hub connections or gears is identical between the eAssistant and the TPK because both coming from the same development platform. To show you how you can use a gearbox housing or you can consider a gearbox housing in a multi-shaft system, I move to the system environment, to the SystemManager, and here I will generate a very simple single stage gearbox with the shafts and with the bearings and the gears, of course, and after this we will integrate the gearbox housing. The SystemManager is a real multi-shaft system. That means you have in the background a multi-shaft finite elemente model, and the gears are the nonlinear coupling elements. And so you have a lot of possibilities with the easy to use. So now I will start with a simple single stage gearbox. So for this I go in my navigation tree to the shafts and right mouse button and I add a group and I add another group, and in the second group I add also a shaft. So now we have two groups and two shafts, and I can rename the group, of course. I select the group and I say this is group G1, for example, and this is group G2, and this is shaft 1 and shaft 2. Okay, and for first shaft I will input also the speed as my input speed, like 1000 RPM. Okay, and the speed of the second shaft should be calculated by the system, of course. Now I go to the geometry for the first and I insert a shaft element, a shaft segment with a length of 100 millimeters and diameter 17. So due to we have a finite elemente model, we need every time a shaft geometry, of course, but we can start with a very simple shaft like a beam, and later we can go more in detail with shaft shoulders and so on. You can see this in different other video tutorials. Today is the focus on the housing, of course. And now I go to the loading and I insert here a loading, and at first I use the coupling, and this is my input coupling, and here I insert the position of the middle of the element and the width with 10 millimeters and a torque of 100 Newton meters, and the shaft is driven. And as next I insert another load element, and this is a load element cylindrical gear, and this is my pinion. And the pinion is on position 55, for example, and the face width is 30, and the number of teeth is 24, and the normal module is 1.5, for example. The profile shift, I leave it open. We can do it later. The normal pressure angle should be 20, and the helix angle should be 12 for our example, and the helix direction is right hand for the pinion. And now I go to the supports, and here I insert a support, and the support is my roller bearing, and this is my bearing 1, and my bearing 1 is on position 20. And now I can go to the database, and I can select here my kind of bearing, of course. I select the deep groove ball bearing because I need only a bearing for this. And here I select a bearing. We have different bearing manufacturers here, of course. And I select here this bearing from FAG. Okay, and this is my fixed bearing for both axial directions, of course. And now I add a second bearing, on position 92, for example, and this is my floating bearing, and I use the same from the database. Okay, and now I'm finished with the first shaft. Now I can go to the second shaft. For this I can duplicate the first shaft, and I can move this in the second group, or I generate it completely new, or I can insert this from DXF to D or step. This is also possible, but now I do this manually here. The speed is deactivated. It's calculated by the system, of course. The geometry, I insert here a shaft segment with 120 millimeters and a diameter of 25, for example. And now I go to the loading, and I insert a load element, and this is again, of course, a cylindrical gear, and this is my gear on the position 55, face width also 30, and the number of teeth is 54, module 1.5 again. Helix angle, of course, the same, 12 degree, but the direction is now helix left hand. Okay, and now I have to insert also the supports, and for this I insert here a roller bearing, and this is bearing number 3. Again on position 20, a deep groove ball bearing. I will select this from here, and for this I'm looking for maybe this. Okay, and I add a second on the same shaft on the same position 92. Okay, and now we need the output torque, and this is also constraint, and so I insert another support, but this is coupling for reaction torque, and so this is our output. So the program calculates the output torque automatically. Yeah, and like this. Yeah. Okay, so now we can go to the shafts, and we see here now all shafts in one. And so we go to the gear connections, and here we insert a gear connection for the cylindrical gear pair, gear 1, and this is shaft 1 with a pinion together with shaft 2 with the gear. And the calculation should be with a TPK, for example, but you can select this also here for the E-Assistant. This is the configuration of the system manager only. Yeah. And for the positioning, we insert again a positioning rule, and here we use the simple thing, group according to gear pair, and in our imagination we say the group 1 is fixed on the 0.0, and so we make the positioning for group 2 relative to group 1 with this gear pair. And here the angle is minus 90 degree. Okay. And now we go to the shafts, and now we see here our shaft system. Yeah. And now we can do a first calculation. And after this first calculation, we can specify also the center distance a little bit more. Now you see, of course, it's not a really beautiful example from a practical view. So you see the bearings have too much load. This is the advantage of this example. That means you see here also the elliptical, the pressure elliptical here, and so it's very red. So you see the lifetime of the bearings are very, very small. Yeah, but this doesn't matter today for this example. And now I will specify the center distance in detail, and for this I call the single calculation module directly here. And now I'm in the single calculation module of the eAssist or TPK, and I can specify the working center distance. I want to have 60, for example, and now I make the layout for the splitting of the profile shift coefficients with this calculation button, and I select balance specific sliding, for example. Okay, and I go back, and now the system is completed, updated automatically with this new center distance. And now I will save this before I insert the housing. So I save this. Like, yeah. Okay. So, and as the next step, I will insert the housing. To insert the housing in the multi-shaft system, I go again to my navigation tree, and with the right mouse button on shafts, I can say add elastic part as housing. And now I have a new item in the tree. I click on this, and here I can change the name, for example, housing. And here I can say import CAD geometry, and with a plus button I can select, or I can import a step file, IHS or Nastran-Nets grid. If you're coming from the finite elemental system and you have done your own grid or mesh, you can import this, of course, or STL is also possible. But the easiest thing is you have modded your housing in a CAD system, and you do the export via step or IHS, and after this you can select this here and open. And now we can specify the maximum mesh size. For this small gearbox it's enough, and I use the alternative meshing method on the surface, and here I use, instead of tetrahedral mesh, hexahedral mesh. Okay, and now the program has imported this and have done already the mesh. Yeah, so, and here I can specify, of course, the material, and here also the temperature of the housing. Now we want to do the positioning, so that means we need the right or correct position of the housing regarding to the multi-shaft system. Yeah. And to see this a little bit more in the 3D view with the shafts, I say show mesh, and I change the transparency a little bit with the alpha channel And if I go back to the shafts, I see this here now. Yeah. And now I will rotate the housing regarding to the shaft system. And for this I go to the positioning. And I have to do more than one rotation, so I use this as a permanent coordinate transformation. And my first rotation angle is 90 degrees, and the rotation vector is around the Z axis. So I say with -1, that means minus 90 degrees. I say OK. And now I see it's rotated. Yeah. And as next, I need another rotation around our x-axis, the red one. So I go back to the housing, make another rotation with a rotation angle of 90 degrees around the x-axis with minus. Okay. And now I see, oh, this was a little bit the wrong direction. So I want to have this shaft on the larger holes here. And so I have to add another rotation with 180 degrees. So go to the transformation, and yes. Okay. And now I need positioning in the different directions. So I say here in the Y direction, I use this with -60, and in the Z direction also -30, and in X with 55. Okay, something was wrong. I think the Y direction doesn't work, so I will change this. 60. Yes, now it looks fine. Yep. Okay, now the housing is on the correct position, and as next step we can marry the housing with the bearings or with the multi-shaft system together. So we go to the housing, and now we see here we have different holes, of course, and you see this borehole has two colors, but we need only one color for only one complete cylindrical surface here inside the borehole. And so I select one surface and a second surface, and now I select both with Shift key on the keyboard, one and the second, and now I say right mouse button, merge with faces, and now I have one surface here. And I will do this with the other. Select this and this, and now I merge this. Okay. And from the positioning here, this is on position 21. This is correct or corresponds with my first bearing, and so I can say select. This is my a little bit small. This is my first bearing, and this is my second on the first shaft. And for the connection type, I mean the average, so the borehole can have also some deformations. Yeah. Okay, and now I do the same with the larger. So this is one surface, one cylindrical surface, okay. And from the positioning, this is bearing 3. And again, connection type is average. And here I select, and this is bearing 4 and also average. Okay. And now I have to connect the housing to the environment, of course, or to the basement. And so I select this with double click the surface, and I say this is fixed and ridged. And so I'm finished with this. Yeah. Now I can go to the general, and I can say support the model analysis, calculate the displacements, and calculate the mode shapes, of course, and consider the stiffness, of course, for your housing. And now we go back to the shafts, and we can say calculate. And now the program calculates from this 3D mesh part the reduced stiffness matrix for the housing in the initial calculation period. And after this, in the second calculation, only the reduced stiffness matrix of the housing is used if you do not change the 3D housing, of course. And so you can work also very easy with a load spectrum or something like this. And now we can go to the system here, and we can say we want to calculate also the eigenfrequencies or natural frequencies, of course, and say here maximum frequency 10,000, and the gears also as stiffness. And now I can say calculate again. Now it's finished, was fast, and I can go to the frequencies, and I see now also the mode shapes here for this gearbox, for this very simple gearbox. Yeah. And also again. Yeah. And yeah, if you see here this mode shape number 4, this is on a speed of 1000 RPM, and if I go back to the housing and I deactivate these things here, I go back and say calculate, this value is changed is 116, so you see the influence of the housing directly here on the eigenfrequencies, of course. Yeah, and again here. You have also the influence on the line load for along the phase width for the gear mesh to optimize the flank modifications. And for this you can call here the graphics connections and here the line load, and this is the current line load, of course. And now I can change this with the modifications like this. So I can go to the 2 flank modifications for this gear pair. I can add a helix angle modification with, for example, minus 0.012. I do again a calculation. Oh, it was a little bit too much. I go back. Yes, and I add also a grounding like only to show how it works. And now I can freeze this diagram, for example. Okay, and now I go back to the system. I deactivate the consideration of the gears as stiffness, for example, and call again the line load connection and say now calculate this. Now we see the difference for this. Yeah. And I can say now also right mouse button, copy from diagram, and now I have both line loads in one diagram. And here I can say for diagram options I want to have only these values, and this is from the other diagram, and I can select here also this, and I can compare this directly here in one diagram, for example. Yeah? Only to show what has happened or how you can compare different things in a diagram. Okay, so we are finished with our small example to show you how you can integrate a housing directly in your multi-chef system. If needed, you can use also a second order mesh, and here for the settings you can make also a remesh. This is also possible, so you have here also different options. Yeah. Okay, so now I'm finished with this, and if you have some questions or do you want to test it by your own, we can provide you also this example here, also with the calculation files and also with the step of this housing model. So you can ask for a trial version, free of cost, of course, and you can contact us via our email info@gwj.de or via our website, and so your feedback is really welcome. And for today, I say thank you for your time and bye bye.